it's helpful to have like a computer session too, but I don't really know how this computer labs work. All right, so any questions on the homework? Let's just walk through this. Most of it I just wanted you to get used to trying them, God bless you, converting them back. Is everybody comfortable switching them around? Log equals exponent. When I was in school, this is how I learned it. The base is on the bottom. So the base is always going to be the base of your exponential function. And the teacher that I had years ago said start at the bottom and circle around. So it's 32 raised to this equals that. Because there's your equal sign. 32 raised to this is equal to that. So if you take 7 raised to the -2 equals that. That works real fast. I mean, anything that you find that works for you is fine with me. That's another one. Come up with your own, that's fine. Turning this around, remember, if you start with log equals exponent, you're going to put the log word, this is the base, this is the exponent, it goes out here, and the 125 fits right here. And try it on your calculator. Make sure that it makes sense. Can everybody go back and forth? Yes? Okay. I want you to be able to go back and forth. Converting it. Sorry, this is my... Everybody's good with that? Stop me if you're not. Okay. Did I give you this part?
Yeah, you was
23 and 25. Okay, so we're putting this in. You can do it very simply. Put it in your calculator with your base formula. This totally works with your base formula, but if you're going to solve it without using your calculator, and you're going to have to find a way to do this, flip this to an exponential equation. Just set this equal to x. 2 to the x is equal to 16. Bring those down to the same base. Logs are exponents, so all the things we use in exponents, we can use in logs. Same thing here. Flip this around, set this equal to, put this in here, and set it equal to something, flip it around and convert that. Be careful on your fraction. Convert your fraction to a base 10. Everybody okay with that? Usually these go pretty good. You get nervous, but now I think you had a little exposure to them, so it's a little bit easier the second time around. A little bit easier for you now? A little bit understanding? You know, that first time that you get exposed to something, everything is like scary. It's like, oh, I hate logs, I hate this. But then you realize you did learn about them. Okay, so we were just looking at transformations. Again, try to do this without your calculator. See what you can get from there. Now, if you want to switch this around and put the +4 over here, this still has a negative in front of that, so that's going to give you a reflection. Base 2, base 10, base 5, same as exponentials. They work the same. They're just a little tighter, but we're sketching. So I just want the basic sketch of the curve. Don't worry about, oh, base 2 is a little wider, base 10 is a little smaller. Just give me the sketch of your curve. Again, your domains and your ranges and everything swaps. So if you struggle with figuring this out, do the exponential one and swap everything. Your asymptote 2, instead of being your x-axis where y is equal to 0, it's going to be your y-axis where x is equal to 0. And now anything horizontally will make that change. Anything vertical won't change this one. Before we found your y-intercept, you can find your x-intercept. And you can switch these around. Some of them you might not be able to, but most of these you pretty much can. And after today, you'll be able to solve everything as well. Good? And we didn't say here, but your asymptote is x equals 0. That didn't change. I don't think I asked you for an asymptote, but good. Stop me if you have any questions. This was a nice one. This was just a vertical shift. Again, the vertical shift isn't going to affect your asymptote. It's going to affect your intercept, but not your asymptote. Domain and range will still be the same. I said you didn't have to do the intercept yesterday, but just kind of keep track of, before we could do the Y, John could do the X. After today, you could do them all. So I figured one more day and we'll just do them all. These were flippable. Okay. Number 59. You had a couple of things going on. You had a horizontal shift. If you want to bring this guy over here, put the -2. You have a vertical shift down 2 units. Your vertical shift won't change anything, but your horizontal shift will. It'll change your intercept, but not your asymptote or your range. Good? Guys, you good with this? Are you doing this without your calculator?
Yeah.
Good.
Which one is your final one?
Yeah, it's a nice solid.
Which one is my final one?
Yeah.
It probably is this red one. Because the blue one looks like a normal curve. And the other one looks like it's shifted over. And then moved down 2 units. It's that final red one.
Can you go back to the 57 one?
Mm-hmm. That negative in front, the minus, is a reflection. You can move the 4 over here. You can put this +4 over here. But this negative is a reflection. And 60. We've got a horizontal shift again, and we have a vertical shift up. For some odd reason this came down here. I think it's just different versions of Word that I use. Are we good with this? The base E ones? I want you to get comfortable with the base E. I want you to be comfortable with those guys. What?
Should we copy down the intercept?
No, I told you not to worry about them. Because after today, you can do them all. I mean, most of these were all doable algebraically, but I figured we'll just throw them in today, after today. And properties. Make sure you understand your properties. Your LNE, don't forget we said that's going to cancel out to 1. If I cancel this out to 1, doesn't that make life a little bit easier? Here's this guy. I worked them out just in case, but get used to your properties. If we take this out, and this is a 1, there's your answer. So get used to your properties. Take this out. Questions at all? Are we comfortable with these? And you do have your nifty little calculator thing, but if you have to do this without using that little extra piece, just draw a line like this. And you're changing base 4 to base 10. Because your calculator, when you see the little log button is base 10. So if you're going to be able to use that, and you don't have that change of base ability in there, you just change this to a base 10. So you take the top, and you leave the one on the bottom, just like that. And that'll put this back into base 10, and you can graph it, you can do an equation off of it, whatever you need to do. Okay, and that, most of the time, and then here, you can always use that base key. The ability there. Sometimes when you go to college, though, they don't let you use, even some colleges don't let you use graphing calculators. Okay, now, your 3 rules. I like to say there are 4, but there are 3 basic rules, and then we're going to add my rule in there. Okay. Because logs are like exponents, they are exponents. We're going to worry about all your exponential rules when we do this. So when you multiply like bases, what did you do to the exponents? You added them. So when you're multiplying in a log, you're going to turn it into an add statement. Same thing. You multiplied exponents, bases, like bases, you added their exponents. So when you see a product of something, you're going to turn that into an add statement. So you're just going to separate these two pieces. We're going to keep the same base all the way through. And we're just going to separate it. It works the same in base each with a natural log. This is where my product is. I'm just going to separate it into an add. When you're thinking these, think exponents. So when you multiplied like bases, you added them. So when you multiply logs, you add them. When you divided like bases, what did you do to your exponents? You subtracted them. So when you're going to divide or you find a quotient there, you're going to subtract them. So our quotient says, a division just says take the first one, subtract the second one. Keep the same bases all the way through. Do you have to write base 10? No. But any other base you have to write. Same thing with the natural log. Your power rule is the most important rule. This is the only thing that brings down this exponent. Now granted, if there's a square there, we wouldn't need to bring it down, but when your variable is up there in your exponent, you're going to have to use a power rule. So once everything is done, this guy just comes down in front, whether it's a log or a natural log. Good? And we have one more. It's called a root rule. So if I took the log of the cube root of x, the first thing I want to do is get all my roots, my square roots, my cube roots, my fourth roots, whatever radicals are there, I want to get them out of there. So I'm going to convert this guy to a fractional exponent. So I'm going to take this is my x to the 1, and whatever index is in here is the bottom number in your denominator. Keep this one, and it would be 1/3. A square root is 1/2, right? If it said this, what would that be? To the what? 4/5. Good. So everybody's okay with that? So convert that out of there. You got to get that radical out of there. And now you can use your power rule to bring it down. Just get that radical out of there and then use your power rule. One thing that gets tricky is this. So what do I have to do first to break this down? You move the 2. Let's move the 2 out in front. Then what? You break the x and the y down. So how should I do that? 2 ln x plus ln y? Okay. So now, if I bring this back, okay, let's work with what Lane has. When I bring this back, where does this 2 go back to? It only belongs to the x. It doesn't belong to the y. So this needs a little set of parentheses here.
Yeah, I had them in my head.
But you did exactly what I wanted you to do because that's what I wanted to show everybody.
I was just trying to
I went to the right person to model this. So now this is going to come back out here. Do you see the difference? He sure did. I set him up for that.
Yeah, we
talked ahead of time. Wait. Can you write it as what? 2? No. This is different. So let's try a little experiment here. In your calculators, let's let x equal 1, let's let y equal 2. Plug this in. Just plug it in like you read it. And then plug this in. See if they're the same. Let's try something. Are these the same? No, right? Because this says what? Give me ln of 3. This is different. This is the log of 1 plus the log of 2. So we can't do it this way. Okay? So don't do this. This is what our rule says. When you separate this, your rule says you have to take this and both of these get the log word. Both of them get the log. You're now taking the log of that. What you remember, Amani, is sometimes we did this. 5, well, okay, let me start. I don't know what happened here. I don't know what happened. All right, let me just X out of this. All right. I don't know what happened here. Right, we're obviously not getting that far. What you remember is this, and this was a famous one. I'll just keep it right here. This was a famous one on the Regents. Okay, this is what you're remembering. So it said the log of 5 plus the log of x plus the log of y. And then it said let the log of x equal 2. And then you had to, once you separated it, you had to go in and replace this, you had to replace that, and then you probably added them all up together. Everything got replaced with something. That's like, I'm not sure I'm getting the right example, but it's somewhere along Algebra 2 loves replacing those things. They'll say, if you see the log of x, replace it with a 2. If you see something else, replace it with a 3. Okay, we didn't get very far, guys, so I'll tell you what. Tomorrow, there's no homework tonight. Hold off the homework, and we'll do these together tomorrow. Okay?